Hello class. We're going to try to do the lecture of Unit 3.5 where I try to do this at home, and we'll just see how this works out and see if this gives a little bit more clarity to that assignment. Okay, so let's start off with number 1. Okay, so we're solving from 0 is less than x is less than 2 pi. Okay. And we're going to solve sine of 2x equals 0. So there's actually more than one way to solve this problem. Okay, so one way we can do it is use the double angle formula. Does anybody remember that? I wish you could answer, but I'll answer for you. We have 2 sine x cosine x equals 0. Okay, so here then we have two choices, okay? We two things that could be 0. We either have sine x equals 0 or cosine x equals 0. Okay, so sine x equals 0, just from 0 to 2 pi, we know that that's just going to be 0 pi, 2 pi. Okay, cosine is 0. It's fun to draw that graph. Okay, so we have pi over 2 or 3 pi over 2. Okay, so that's one way to solve this sort of problem. Okay, we're going to save this. And now, okay, put that away. All right, we're going to go ahead and do the same problem a different way, which is to make a substitution. Okay, so solve the second way. We're going to have sine of 2x equals 0. We're still solving that one. Okay. Now, this time, what we can do instead of using the double angle formula, we can make a substitution, okay? So, first of all, before we do that, let's think about what sine of 2x looks like, okay? So, regular sine looks like pi 2 pi, like that. Whereas, sine of 2x is going to have half of that period. Okay, so their solutions are going to be more frequent. And in fact, you could just get it off the graph if you wanted to. That would be totally fine to do it that way, to just grab those solutions off the graph. But if you wanted to add an algebraic component to it, one thing to realize is that if you do a substitution, you have to look a little bit differently at this problem than that problem. Okay, so I'm letting theta equal 2x, or x equals theta over 2. Okay, so for this problem, if I'm solving this one, obviously the solutions here are 0, pi, 2 pi, right? Okay, but the problem is on this one, I'm going to have to actually look further, okay? Because what I have to do is, in other words, I'm thinking about this graph and this graph, in other words, so, like, I'm going to have to look all the way to 4 pi, because I'm going to take this stuff and squinch it to here, okay? So let's be sure we get all of those solutions, okay? 0 pi, 2 pi, 3 pi, 4 pi, for this, for theta, okay? So theta are those values, right? And so, if I divide theta by 2, I get x, so I could take all of those answers and divide them by 2. Marker failure. Okay, so 0 divided by 2, then pi over 2, then I'm going to get pi, 3 pi over 2, and 2 pi. So of course I get the same answers that I got the other way, okay? So I think what you just need to do is, when you make a substitution, you just need to account for the stretching or shrinking that's going to happen with that substitution. And so I think that's the subtle part that's a little bit harder for some of these cases. Okay, so let's see here. Let's do number 4. I'm going to jump ahead. I'm going to assume that you